Lesson 7-2, Division Properties of Exponents. The objective is to divide monomials using the properties of exponents, and also to simplify expressions containing negative and zero exponents. The standards, Algebra 1, 6.2. So first of all, we're going to talk about powers with quotients. It kind of follows what we did yesterday. When you multiply something with the same base, you add the exponents. But today, the division property, when you divide the same base, you subtract the exponents. And we talked about this a little bit last year in pre-algebra. So you don't really change the A remains the same, and it's m minus n. So just to kind of show that to you, in that very first example, I'm going to spell it out a little bit more than I would for the rest of them. I'm going to go ahead and show you example A just so that you see it. We have 5 A's on the top and 2 A's on the bottom. So if we didn't know that property, you'd have to do something like this. A, so 5 of them up there, and they're all being multiplied, and 2 of them down on the bottom. And it's just like any other fraction. If you have a common factor on the top and bottom, you cancel them out. And what would be left? Well, 3 A's, a to the third. But now it's so much simpler that we know that property. 5 minus 2 is 3, so it's just a to the third. Probably as I'm doing this, and I would recommend for you, when you write a to the fifth down over a to the second, I would just do this. There's 5 on top, and there's 2 on the bottom. And I think to myself, how many can I cancel out completely? Well, 2. So I would just mark these out completely, and then I'm thinking, all right, I'm going to take 2 away from that 5, and that leaves me a to the third. That's kind of what we're going to be doing here, because they're not going to just give you one letter to reduce. They're going to give you multiples like B, and even more involved than that. Okay? So let's look at B, and if somebody wants to help with this one, that'd be great. X to the 7th, y to the 12th, over x to the 6th, y to the 3rd. So Jared, let's start with the x's. What can I cancel out? How many of them can I cancel out? Yeah, so that means all of these would be gone, and my 7 on top would become a 1. So there is going to be just x to the 1. And then my y's, how many can I take out? 3. So all of them are gone on the bottom, and how many? My 12 becomes a 9. So my final answer, Jared, would be what? X, y to the 9th. All right. Now, on C, it's a little more involved. It's basically a power on a power, and I don't see any common things on the top and the bottom that can cancel, do you? No. So I think what they're doing is they're just kind of developing the power on the power to a, it's called a rational fraction, but this one, you take everything to the 3rd power. So does anybody want to try that? Okay, Ethan, what would 4 to the 3rd power be? 64. And what about C to the 3rd? What would that become? C to the 9th. And then D squared would become?
D to the
6th. Okay, and on the bottom, 5 cubed would become 125. E to the 4th would be
64.
E to the 12th. And then F to the 7th would become F to the 21. So you're multiplying the power on the powers of the variables. You're taking the numbers themselves and multiplying them that many times. Now, at this point, if there would be any common thing from top to bottom to cancel out, you definitely should do that. but I believe 64 and 125 don't have any common factors. So that is the final answer. Any questions about that? Canceling things from top to bottom or taking things to powers and then canceling. All right, moving on to this. This is something we talked about a little bit last year. Anything to the 0 power is 1 by definition. That is a definition. Anything to the 0 power is 1. So even if they have this long involved monomial, x to the 5th, y to the 10th, z to the 8th, if it's all to the 0 power, then you must say the answer is 1. So in these problems, as they become more involved, what I would highly recommend as you go through, right away, anything to the 0 power, go take it out or definitely cross it out and put a 1 there so that you're not dealing with it as you go. Okay, because they might make it look a lot more complicated than it is, but when you take those out, it simplifies it quite a bit. So anything to the 0 power is 1. Sometimes kids get confused and they think, oh, 0 power, it must equal 0. But no, that is definitely not true. Anything to the 0 power is 1. So let's look at some examples that involve this. Or I guess just one example. M to the 0, n to the 4th over n to the 2nd. So anybody want to try to do this one? All right, Josh. So what do you think we're going to do with this?
So the m to the 0th power would just go straight to 1.
This one would just go straight to 1. And then we've got those n's. What are we going to do with those?
So then the n2 would cancel out. You'd have n2.
Okay. And then this one, the 4 would become a 2 because we've got 4 n's on top and 2 n's on the bottom. So, Josh, when I kind of clean all that up, what's my final answer?
N to the 2nd.
N to the 2nd. Okay. Questions about that? Yeah.
What if one of the zeros parentheses and then 0? Would it just be the same exact thing?
If any, it'd be just like this right up here. See that? The whole thing would become 1. The whole part of it would become 1. Okay? You could mark out that whole set. All right, anybody else? All right, let's now move on. And when we talk about division, it brings up negative exponents. And negative exponents were definitely introduced to you last year in pre-algebra. To kind of show you what we're talking about here with negative exponents, negative exponents, a to the negative n. The way that you remove the negative exponent is you take that base and the exponent to its opposite place. So if it's in a numerator, like this one right here, you see it? It's just sitting there, right? Anything that's just sitting there like that, it's not a fraction, it's automatically over 1. Just like any number, and you guys know that. It's automatically over 1. So that means this thing right here is in a numerator. To get rid of the negative exponent, you just take it to a denominator. The base stays the same, the exponent just becomes the positive. Now, if that negative exponent on a base is in a denominator, you move it up. The base stays the same, the number of the exponent stays the same, except it becomes its opposite. So this says something really important: move negative exponents to the opposite, numerator, denominator, and it removes the negative. Everything else stays the same. One other thing, just like I've been talking to you about standard answers, okay? Standard answers. One of the standard things is you can never leave a negative exponent in an answer unless the directions say write it with the negative exponent. And the only time, honestly, that would be happening is like a section of problems we did in pre-algebra where we first did it just to see if you understood what would make it a negative exponent. But pretty much from algebra on, never leave a negative exponent in your answer. Okay, so see how those things are defined and what they look like, and now we're going to look at some examples here. Our job is to simplify it in every way. Don't leave common factors top to bottom. Don't leave negative exponents in your answer. So example E, it's just a to the negative eighth. If you came up with an answer like that, you could not leave that. What do you think you would have to write? Megan? 1 over a to the eighth. And then you're done. There's nothing else you can do that. 1 over a to the eighth. All right. F. X to the negative fourth, y to the ninth, and z to the negative sixth. We actually did this in enrichment. Everybody remember in this? So anything with a negative exponent, you should take it to the opposite spot and then go back and look and see if you got anything to cancel. So that x to the negative fourth, should it stay or should it go? Go. So if it's on top, I'm taking it down to the bottom. The y to the ninth, should it stay or should it go? Stay. So y to the ninth. The z to the negative 6, should it stay or go? Go. So we're going to have to take it to the top. So y to the ninth, z to the 6th over x to the 4th. Anything cancel? No. So that actually would be my final answer. Y to the ninth, z to the 6th, x to the 4th. Questions? Yeah. Oh, you ready to do the last one? All right, this last one. 75 p to the third, m to the fifth, or negative fifth, sorry, over 15 p m to the negative fourth, r to the negative eighth. Boy, there's a lot of stuff going on here, isn't there? I still highly recommend that you take care of your negatives first, except my tree, I think the 75 and 15, we could probably go ahead and reduce that, right? How would those two reduce? Yeah, we can divide both those by 15, 1, and 5. So I'm going to put a 5 on top. So that's taken care of. Now my tree, what I'm going to do is I'm going to go across the top with every variable, and you're telling me whether to leave it or take it to the opposite spot. So p to the third. Leave it, so I'd leave p to the third. M to the negative fifth. So I'm going to take it down here as m to the fifth. Okay, so we've taken care of the whole top. Now let's go bottom left to right. How about the p? Stays. M to the negative 4. Opposite, so m to the 4th, and then r to the negative 8th. So it comes up here as r to the 8th. So we're definitely not done, but we've gotten rid of all the negative exponents. So I'm going to do this. I'm going to take my 5. Now, let's try to do alphabetical order and see if we can do our answer all at the end. So alphabetically, our m's would come next. I've got 4 m's on top and 5 on the bottom. How's that? What's going to be left and where? There's going to be 1 m left on the bottom because you take all 4 of those away, and that makes the 5 become a 1. Okay, good. Next, the p's. There's 3 on top and 1 on the bottom. What are we going to do? 2 p's left on the top because this one's gone completely, and that one, the 3, becomes a 2. And then finally the r. R to the 8th just stays put. There's nothing to cancel, and that would be our final answer. Questions about that? Yes?
If there was like, if they were exactly the same on the top and the bottom, would they just cancel each other out?
Yes, if there was the same amount on the top and bottom, they would just both cancel out completely and you would not write that letter. If everything cancels out on the top or the bottom, that takes it to a 1. If it's on the bottom, you don't write the 1. And if it's on the top, you definitely have to write the 1. Did everybody hear that? Let me show you this really quick. What if you had m to the 4th over m to the 5th? So I'm adding a problem here. M to the 4th over m to the 5th, and that's all that was there. What's going to cancel out? Ben?
The ends. They're going to go to the negative first, and they're going to put 1 over the
Yeah, there's all the m's on the top are gone, so there's 1, and then m to the first on the bottom.